What if the universe has been quietly sending us visitors for billions of years, and we only just learned how to see them? Something from another star system slammed into Earth's atmosphere in early 2025, and the satellites built to watch for missile launches caught the flash. It was moving at roughly 59 kilometers every second. The sun's gravity can only hold onto objects moving slower than about 42. Whatever hit the sky that day was not ours. It came from somewhere else entirely. And it was not the only one. Before we go any further, do me one small favor. If the idea that other star systems are dropping pieces of themselves into our own backyard makes your skin prickle in the best way, hit that like button. Share this video with one person who loves space. And subscribe so you're here the moment the next visitor shows up. I promise you, by the end of this story, you will understand why that matters more than you think. Now let's back up, because the strangest part of this story is how fast everything changed. For all of recorded human history, we never saw a single object from another star system pass through our solar system. Not one. The universe is enormous, objects are tiny, and for most of history our telescopes were simply not sharp enough to catch something moving that fast, that far away. Then, in 2017, everything shifted. That year, a telescope in Hawaii spotted a faint streak of light moving on a path that no object born in our solar system could follow. It was named Oumuamua, a Hawaiian word that means scout or messenger, and it was strange in every possible way. It had an odd, elongated shape like a cosmic cigar. It had no tail, which is bizarre for anything that behaves like a comet, and it accelerated as it left, speeding up in a way that no natural explanation could fully account for. Scientists spent years arguing about what it was. A comet? An asteroid? A fragment of something bigger? A piece of alien technology? Every answer felt wrong. That is exactly why it was so exciting. Then in 2019, a second visitor arrived. It was named Borisov, after the amateur astronomer who spotted it. And Borisov looked normal. It had a proper tail. It behaved the way a comet should behave. It gave scientists a deep, collective sigh of relief. See, they said, interstellar objects are just comets from far away. Nothing weird about them at all. For a few years, that comfortable story held. 2 objects in 2 years, after 0 in all of human history. That alone should have told us something important about how common these visitors really are. If you find 2 in 2 years after finding none for thousands, the honest conclusion is not that they are rare. It is that we were not looking hard enough. Think about it this way. If you stand in a dark forest and hear 2 footsteps in 2 minutes, after hearing nothing all night, you do not assume the forest is empty. You assume you finally started paying attention. That is exactly where astronomy found itself in 2025. We had just started paying attention, and we were not ready for what came next. In early July of 2025, a third interstellar interloper was discovered. It was first given a temporary designation, a string of letters and numbers that meant nothing to anyone outside a small circle of astronomers. Then, within days, its orbit was computed. And the orbit said the same thing Oumuamua's orbit had said 8 years earlier. This object is not from our solar system. It was confirmed as the third interstellar object ever detected, and it was given a name that would soon be on the lips of every astronomer on Earth. 3I Atlas. The Atlas Survey Telescope in Chile caught a faint moving point of light on the 1st of July 2025. Within days, the orbit was confirmed. And that is when the trouble began. Because 3I Atlas was different from the first 2 visitors in ways that immediately started making astronomers uncomfortable. Every plan we had made for the next interstellar object assumed it would look like Oumuamua or like Borisov. This thing looked like neither. One professional astronomer, writing in the scientific literature, described this situation with 2 words that rarely appear in a peer-reviewed paper. Crazy and exciting. Not the words of a YouTube channel. The words of a scientist, published in the permanent record of human knowledge. When scientists start using words like that, you should pay attention. Scientists are trained to be boring. They hedge, they qualify. They say further research is needed. When a working astronomer breaks character and calls something crazy in print, that is the closest thing astronomy has to a scream. The first difference was speed. 3I Atlas was tearing through our solar system at about 130,000 miles per hour. That is far faster than either of the 2 previous visitors. Fast enough that it had been wandering the galaxy for an almost incomprehensible amount of time. Calculations suggest it had been traveling for 10 to 12 billion years before it ever came near our sun. Think about that number. Earth is 4.5 billion years old. This object began its journey before the planet you are standing on even existed. It was already ancient when the first single-celled life on Earth was just figuring out how to divide in 2. It has been moving through the dark, alone, for nearly 3 times the age of our entire world. Every human being who has ever lived was born and died while this object was still on its way. The second difference was size. Oumuamua was roughly the size of a football field. 3I Atlas is a completely different scale of problem. Observations from the Hubble Space Telescope placed the diameter of its nucleus somewhere between 1,400 feet and 3.5 miles. At the upper end, that makes it a mountain, drifting through our solar system like it owns the place, and that size created an immediate statistical crisis. Here's the problem, and it is a beautiful one. In any population of objects, small ones are far more common than large ones. If interstellar objects exist in large numbers, we should see a huge pile of small ones. It is like fishing in an ocean where you expect to catch mostly sardines, and your very first catch is a whale. Harvard astrophysicist Avi Loeb put it bluntly in a paper published almost immediately. By our models, we should have detected on the order of 100,000 Oumuamua-sized objects before discovering something as big as 3I Atlas. We saw one small object in 2017, and then jumped straight to something potentially 1,000,000 times more massive. That does not fit any known distribution. Something in our models is wrong. That is where the story stood in the summer of 2025. A strange, vast, impossibly large object, breaking every expectation we had. And then the science teams did what science teams do when they meet something they do not understand. They pointed every major telescope on Earth, and in space, directly at it. The James Webb Space Telescope, Hubble. The Subaru Telescope in Hawaii, the ALMA Array in Chile, even NASA's Europa Clipper spacecraft captured observations. 12 separate NASA assets alone photographed and processed imagery of this object. The most powerful eyes our species has ever built, all aimed at one passing stranger. And what they found over the following months produced paper after paper, each one adding another layer of strange. The first surprise came from the water. Every comet ever studied in our solar system contains water, and that water carries a certain ratio of regular hydrogen to deuterium, the heavier cousin of hydrogen. This ratio is like a chemical fingerprint. It tells you how cold it was and where when the object formed. Across every comet we have ever measured in our solar system, the ratio stays within a narrow, familiar range. It is a signature of our own cosmic neighborhood, a chemical handshake that says, I was born here. The water around 3I Atlas broke that signature completely. A study led by researchers at the University of Michigan found extraordinarily high levels of deuterium. The ratio of deuterium to ordinary hydrogen in its water was more than 10 times higher than anything ever measured in a solar system comet. Not a little higher, 10 times. Think about what that means. The water that made up this object was formed in conditions so different from our own that the chemistry itself is alien to us. The measurements, published in a leading astronomy journal, showed roughly 1 deuterium atom for every 100 hydrogen atoms. And the carbon isotope ratios were off the charts too, exceeding anything found in our solar system. Quick pause, because this is the part of the story where most people's eyes glaze over, and I need you to stay with me. The chemistry you just heard is the closest thing we have to reading the diary of another star system. If you want to be one of the few people on Earth who actually understands what is flying through our neighborhood, hit subscribe. This channel is for people who would rather look up than scroll. And if this is your first video here, welcome. You are in the right place. Here is the deeper point, and it is worth sitting with for a moment. Our solar system formed in a particular set of conditions. We assumed those conditions were normal, the standard recipe for making a planetary system. The chemistry of 3I Atlas says that assumption is wrong. The conditions that built our solar system are not a universal template. They are one local example among countless others, and some produce chemistry we have never seen and cannot fully explain. We are looking at genuine alien chemistry from a place that formed under physical conditions that simply do not exist anywhere near us. But the water was just the beginning. Then the methane results came in. NASA's James Webb Space Telescope uncovered something no one had seen before. It detected methane on 3I Atlas, the first direct detection of methane on any visitor from another star system. And the methane was not just there. It was there in quantities that made scientists stop and check their instruments. The ratio of methane to water was roughly 11 times higher than any object ever measured in our solar system. 11 times. And the deuterium enrichment in that methane was even more extreme than in the water. Roughly 1 deuterium atom for every 30 hydrogen atoms in the methane molecule. Let that sink in. The most powerful telescope we have ever built was reading chemistry off a passing interstellar object. 3I Atlas is not a weird comet. It is a comet from a completely different kind of star system. The building blocks of this object are so unusual that they read like a message from a different recipe book of the universe. A recipe book we did not even know existed until 8 years ago. The chemistry of life, the molecules that eventually assembled into living things on Earth, came from somewhere. If the building blocks of planetary systems can vary this wildly, then the chemistry of life itself might vary just as wildly across the galaxy. We are not just discovering a strange comet. We are discovering that the universe has more ingredients than our recipe book ever imagined. And then there was the listening. Because when you have an object this unusual passing through your solar system, you point the biggest ears on Earth at it. A search for narrowband radio signals was conducted toward 3i Atlas using the 500-meter aperture spherical telescope in China, the largest radio telescope in the world. The observations ran from October 2025 to January 2026 on 4 separate dates. The SETI Institute ran its own search with the Allen Telescope Array. The result was the same both times. Silence. No signal. No transmission. Nothing that looks like technology broadcasting on radio frequencies. Now here's where it gets interesting. Silence is not the same as natural. The absence of a radio signal only tells us that 3i Atlas is not broadcasting to us on radio. It does not tell us what it is. Avi Loeb's position is that the anomalies in 3i Atlas are real, and they need to be taken seriously rather than explained away. He points to the object's path through the ecliptic plane, the flat disk in which the planets orbit the sun. The chance of that alignment happening at random is about 1 in 500. He points to its size. He points to its composition, which appears rich in nickel with very little iron, the kind of mix we find in industrial alloys. He points to the methane, 11 times higher than any known solar system comet, the deuterium, enriched far beyond anything we have seen. Each individual anomaly might have a natural explanation. That is true, and it is worth being honest about. But the cluster of them, all on the same object, moving through our solar system right now, is what serious scientists are struggling to fully account for. That is the central tension of this story, and it is not going away. Because when you collect enough impossible coincidences in one place, at some point you have to ask whether coincidence is still the best explanation. While everyone was watching 3i Atlas round the sun in late 2025, something else was being quietly calculated in the background. And the number that calculation produced was so large that most people who heard it assumed it had to be wrong. Avi Loeb and his postdoctoral researcher went looking for interstellar objects in a very unexpected place. The United States government maintains a database called the Center for Near-Earth Object Studies Fireball Catalog. It is populated by the same military satellites that watch for ballistic missile launches and nuclear tests. Every time something burns up in the atmosphere bright enough to register, those satellites catch it and record its velocity. A secret weapon built to watch for war, quietly repurposed to count the debris of other worlds. When a 3-meter object collides with Earth, the friction of the air generates a fireball with energy comparable to an atomic bomb. That explosion is easily detectable by satellites designed to spot the heat of missile launches. So Loeb and his colleague went through that database, and they looked for one specific thing: objects moving faster than the solar system's escape velocity, faster than about 42 kilometers per second. An object moving that fast cannot be gravitationally bound to the sun. It has to come from outside. They found 2. The first was detected on the 28th of July 2022, over the eastern tropical Pacific Ocean. It exceeded escape velocity by 8.7 standard deviations, a statistical margin so large that it is essentially bulletproof. The second was detected on the 12th of February 2025, over the Barents Sea in the Arctic, exceeding escape velocity by 5.5 standard deviations. That is the fireball we opened this story with. And then, in April of 2026, a third one arrived. A meteor detected over the South Atlantic Ocean with a velocity component of nearly 60 kilometers per second. Its interstellar origin was confirmed with a statistical confidence of over 99.997%. Let's pause on what that means. Pieces of other star systems are hitting Earth's atmosphere in 2022, in 2025, and in 2026. We have the data from government satellites. The velocities have been confirmed. The interstellar origins have been established at confidence levels that would be considered bulletproof in any scientific context. We are being rained on, gently, by the debris of other worlds, and almost nobody noticed. From those confirmed interstellar meteors, Loeb calculated a collision rate of roughly 1 every 3 years. Then he worked backwards through the geometry of Earth to figure out how many objects must exist in the surrounding volume of space. The answer was staggering. At any given moment, there are approximately 35 million meter-scale interstellar objects inside the orbit of Earth. Not out past Neptune, not in the distant Kuiper Belt. Inside the orbit where we live, 35 million pieces of other star systems, silently sharing our cosmic neighborhood. And we had no idea until about 5 minutes ago, in astronomical terms. We just crossed into the part of this story that most people have completely missed. If you are still here, honestly, thank you. In a world of endless scrolling, choosing to spend 10 minutes thinking about the universe is an act of rebellion. If that is you, hit like and subscribe. And let's keep this tiny corner of the internet pointed at the stars. And they are heavy. Assuming a solid density of a few grams per cubic centimeter, each object carries about 3 million metric tons. Altogether, the population totals about 100 trillion metric tons of interstellar material inside Earth's orbital path, 100 trillion tons of other star systems, threading through our solar system, and almost nobody notices. Here is what that number does to your sense of place. The solar system is not an island. It is not a quiet, isolated bubble floating through empty space. It is permeable. It is constantly being threaded through by visitors from other stellar systems, some the size of mountains, some the size of a car. Some of them, perhaps, carrying the chemistry of life from worlds we will never know. And we are only just now developing the instruments to see them. For billions of years, this traffic was invisible to us. It was happening the whole time, right under our noses. The only reason we can see any of it today is that we finally built the right tools. That is the pattern of science in a nutshell. We do not discover the universe, we simply learn to look at it properly. If these objects are so common, why did we only just notice? Because until recently, our telescopes were not fast enough. Finding one was like trying to spot a single grain of rice flying past a football stadium at night. You need the right camera, pointed at the right patch of sky at the right moment, and you need to be lucky. And in 2026, that machine came online. The Veracruz-Rubin Observatory in Chile is the largest digital camera ever built. It photographs the entire southern hemisphere sky every few nights, producing a time-lapse of the changing universe. And one of the specific things it was designed to catch is fast-moving interstellar objects passing through our solar system. There are estimated to be around 10,000 interstellar objects within the orbit of Neptune at any given time. The best estimates suggest Rubin should detect between 5 and 50 interstellar objects over its 10-year survey. At the upper end, that is one new confirmed interstellar visitor every few months, not every decade. The enormous gap between 5 and 500 tells you exactly how little we actually know about what is out there. Loeb is already thinking ahead to the next confirmed object. He has given it a name for Rubin. His proposal for what we should do when it arrives is one of the most audacious ideas in modern space science, hitchhiking. We should be ready to attach a small spacecraft to it and let it carry our technology back out into the galaxy. A close-up photograph, just before impact, would unravel the nature of future interstellar objects. Even if the object turns out to be a natural iceberg, the instruments on board could check whether that iceberg carries biological signatures. Think about that. We found methane 11 times more enriched than anything in our solar system on 3I Atlas. The next time one of these objects comes through, we have a chance to get up close and actually find out what it is carrying. For the first time, we would not just be watching a visitor pass. We would be reaching out to touch it. Interstellar objects like 3I Atlas travel a few times faster than all 5 human-made probes ever launched toward interstellar space. Every single one of our spacecraft that has left the solar system moves slower than the average interstellar comet. That single fact contains everything you need to know about where we are in the cosmic picture. We are a civilization that has just barely managed to throw a few small probes past the edge of our own star system. And now, for the first time in history, we have an instrument powerful enough to catch them as they arrive, in real time. 3I Atlas came and went. It is now past Jupiter, heading for the outer solar system, back out into the interstellar dark. We had months to study it. What we learned is that whatever conditions formed it are completely different from ours. There is something humbling in that comparison. We measure our progress in decades and our reach in a few billion miles. Yet here are objects that have crossed distances we cannot even comprehend, moving on timescales that dwarf our existence. The next interstellar visitor is already out there, moving toward us at a speed we can barely comprehend. The next chapter of the story is already being written. I want you in the room when it happens. The next one is coming. Rubin is watching. The satellites are watching. The SETI telescopes are listening. The space around us is not empty. It is full of travelers, ancient, silent, carrying chemistry from places we will never visit. They have been passing through our solar system for billions of years, long before there was anyone here to watch. The universe was always talking. We just finally learned how to listen. The solar system was never alone. It was only ever unobserved. Stay curious. Keep looking up. I will see you in the next one.